Here are the solutions to 9 through 12 from the rational equations worksheet. All right, so in number 9, all we have to do, we don't need to factor any denominators here, but the LCD is going to be both of these together, c minus 1 and a c plus 1. The restrictions are from the first two, c cannot equal a positive 1, and then from right over here, the c plus 1, c cannot equal a negative 1. Now, one nice thing we could do with this, notice how the two fractions on the left side already have a common denominator, so we can actually combine this. So we could say we're going to get a 7 over c minus 1 equals 4 over c plus 1. It just makes the problem a little bit easier to go through. If not, you would just still keep, I'll write this over here if you didn't do it this way. We want to get common denominators for all of them, so they'll be made up of c minus 1, c plus 1. So the 5 would have to get multiplied by the c plus 1. So will the 2. And the 4 will have to get multiplied by the c minus 1. Now we can cross out our denominators, distribute our 5, so we'll get a 5c plus 5 plus 2c plus 2 equals 4c minus 4. Combining our like terms, we'll get a 7c plus 7 equals 4c minus 4. And now if I were to go back to this part, we're not done yet, but I just want to show you how we're going to end up with the same thing just a little quicker. So my LCD again is c minus 1, c plus 1 for both of these. And then that means I need to multiply the 7 by the c plus 1 and the 4 by the c minus 1. So now I can cross out my denominators, and I'm left with the 7c plus 7 equals 4c minus 4. So we're at the same step now. All right, so continuing to solve this, I'm going to subtract 4c from both sides, so we'll get 3c plus 7 equals negative 4. Subtract 7. 3c is going to equal negative 11, and divide by 3. So c equals negative 11 thirds. Now our restrictions were 1 and negative 1, so we're good. Negative 11 thirds is our solution. All right, now for number 10, we definitely need to factor both of these denominators. I'm going to do this right underneath. This first denominator, we can factor out an m. We're left with an m minus 2. The second denominator, m squared minus 4, this factors. This is a difference of squares into m minus 2 times m plus 2. So our LCD is an m times an m minus 2 times an m plus 2. What can't m equal? This first m here can't equal a 0. This m here can't equal a 2. Same thing over here, so I don't have to write that again. And then this m here can't equal a negative 2. So I have 3 restrictions. So now I'm going to make both fractions containing the LCD, m minus 2 and m plus 2 for both. Now we go and adjust our numerators. Keep the m plus 3 in parentheses. This had an m and an m minus 2, so we need to multiply by an m plus 2. The 10 had both the m minus 2 and m plus 2, so we just need to multiply by m. Now I can ignore my denominators, cross them out, and I'm left with, I'm going to go ahead and distribute this here. We'll get m squared. Outside and inside terms give us 5m plus 6 equals 10m. Subtract a 10m, that's going to join with the 5m. So 5m minus 10m is going to be a minus 5m plus 6 equals 0. Let's go ahead and factor. This should factor into an m minus 3 times an m minus 2. So my two possibilities here, m minus 3 is equal to 0, so m is going to equal 3, or m is going to equal 2. But let's take a look at our restrictions. M cannot equal a 2, so we cannot keep that one. Therefore, m equals 3 is our only answer. Number 11 is very similar. We have to factor our denominators. This first denominator, we can factor an x out. We're left with x minus 1. And this is a difference of squares, x minus 1, x plus 1. So our LCD is x times the quantity x minus 1 times the quantity x plus 1. What can't x equal? This first x cannot equal a 0. This x cannot equal a 1. Same here. This x cannot equal a negative 1. So now I'm going to make two fractions having the LCD. And because this is 0, well, we know 0 times anything or divided by anything is still 0, so I'll just leave it as a 0. So what this means now is this x plus 2 had the x and the x minus 1. That needs to get multiplied by x plus 1. The 6 had both the x minus 1 and the x plus 1, so we just need to multiply by x. And again, I can cross out my denominators because, again, even if I put this over x times x minus 1 times x plus 1, if I were to multiply by anything, that's still just going to be 0. But if you need to see it, we can still cross out our denominators. Distribute here, so we're going to get x squared plus 3x plus 2 minus 6x still equals 0. Combine our like terms here, so we'll get x squared minus 3x plus 2 equals 0. Factor. This should factor into an x minus 2 and an x minus 1. So x is going to equal 2 or x is going to equal 1. Let's look at our restrictions. X cannot equal a 1, so we cross that one out. X equals 2 is our only answer. And finally, number 12. No need to factor anything here. I do want to point out 1 minus a and 1 plus a, they are not opposites. 1 minus a and a minus 1 would be opposites. So my LCD is all three of these multiplied together. A times, I'm going to leave the 1s first, 1 plus a times 1 minus a. What can't a equal? This a cannot equal a negative 1. This a cannot equal a positive 1. This a cannot equal 0. So let's make our LCDs for every fraction. So we have a, 1 plus a, 1 minus a. And adjust our numerators. So the 2 needs to get multiplied by the a and the 1 minus a, because it just had the 1 plus a. The 3 needs to get multiplied by an a and the 1 plus a. And the 5 had the a, so it needs to get multiplied by 1 plus a times 1 minus a. So now I can cross out my denominators. Carefully distribute here. This will give me a 2a minus a 2a squared. Over here will give me a 3a plus 3a squared. Now off to the side, if I were to multiply 1 plus a by 1 minus a, I want to multiply that together first. I'll leave the 5 out in front. This will give me a 1 minus a plus a, so the a's cancel out, and then we would just have minus a squared. So this becomes plus 5 times the quantity 1 minus a squared. We still have to distribute that 5. Copying everything else down. Now we'll have plus 5 minus a 5a squared. I want to combine my like terms, my 3a squared minus 5a squared over here. I have 3a. That will give me a minus 2a squared plus 5. Now, even though we see a quadratic, if you notice, we have a minus 2a squared on both sides. So if I were to add that, if I were to bring everything over to, say, the left side, these two would cancel, and there goes my quadratic term, so we no longer have to do this. I do want to subtract 3a, though, so just to write out what's left, 2a is going to equal 3a plus 5. Subtract 3a, that'll give me a negative a is equal to 5. Divide by negative 1, so a would equal a negative 5. Now my restrictions were negative 1, 1, and 0, so our solution stays. But as always, guys, if you have any questions over any of these problems 1 through 12, please let me know.